Hello, everybody. There are lots of people joining now. Thanks a lot for being here with us today. We're very happy to do this online conversation with you, which is about how to design for additive manufacturing on the go. And we're ready to begin right now. First of all, I would like to introduce myself. I am Lisa, and I am the marketing manager for Europe at Markforged. A big welcome to everybody. Just a couple of information. First of all, these are going to be our speakers today. Lutz Feldmann, my colleague, he works as regional channel manager here in Europe, in Central Europe, to be precise. And we have Dani Rosner, who's user researcher at Shapr3D. We will have a question and answer session end of this online event. So please, if you have any questions, type them in the question and answer chat. And now I'm very happy to leave the floor to our speakers.
Thanks, Lisa, for the warm introduction and welcome again to this webinar. I don't want to spend too much time on explanation about Markforged. We will see our product live very soon. For me, it's more about the technical experience about how to design for manufacturing or for additive manufacturing, or in particular, how to design for a specific process in additive manufacturing, because I think we need to consider not only the additive process in general, but the specific process we have here at Markforged. As some of you know, we are the company who does continuous carbon fiber, continuous Kevlar, so we lay down continuous fibers into our parts, and we will later on show this live. Now let's hear a little bit from our friend Daniel.
Thanks, Lutz. Hi, everyone. I'm Daniel. I'm doing user research here at Shapr3D. So a quick intro of Shapr. I'm going to do a long session shortly about how you model in Shapr, but just to what Shapr is. So Shapr is a 3D design app made specifically for the iPad and the pencil. It is based on Parasolid. It's the same geometric kernel that, for example, SolidWorks uses. And it is a direct modeling tool. So you will see all the benefits of direct modeling tool later on, but specifically it's very good for small part designs, which I'm also going to show later on, redesigning one of the parts that Lutz is just going to introduce now.
So let's move right away into the task. So this was my job. You know, I got approached by a client and said, well, we want to replace this little assembly, which is just two standard parts, a laser cut cover plate, and a cast and machined metal part, which we use just 10 times a year. It's actually a spare part for them. And we want to try to reproduce it in plastic, actually, but not in regular plastic, but in our plastic, which has continuous fibers inside of it, you know, just to provide almost the same strength as in standard aluminum. With this geometry, I reached out to Daniel. I send over the geometry as a Parasolid file and some design guides. We have developed some design guides, quite obviously, for our process. And with this said, I simply hand over to Daniel.
So you can see my screen now. I'm working on an iPad Pro. So without further ado, I'm just going to import this Parasolid file right into Shapr3D, copy it to Shapr3D, and start the redesign process. So we have this 4-body part here, which we have to redesign into a 1-body part, while making sure that we properly prepare this for metal 3D printing. So this is the prepared file. I highlighted those features that we need to do in order to make sure that it will be a smooth printing process. So this means we have to add fillets to strengthen the corners. We have to create teardrop overhangs so that we don't have to print that much support. So this makes the machining time much less. And also, we don't have to take care of all the removing the support and so on. We also removed some material on the sides and also added some chamfers so we avoid splaying during the sintering process. So let's jump into it. So what I'm going to start with is that I'm going to remove the features that we are not going to need. First, I'm going to union these two together. You should be able to see my pencil and my touches on the screen. The red dots are my touches. I'm going to delete these bolts. I'm going to delete these holes as well. And I'm also going to delete these fillets. We are going to add these later on, but I don't want this to disturb me in the redesign process. I'm also going to delete this mount part. Make sure that it's back. Also delete this hole. We are going to recreate it. And so this is my basic constraints. This is my basic part. And what I'm going to do now is that I'm going to add all those features that will make it ready for 3D metal 3D printing. So first, what I'm going to do is, as opposed to this more circular mount, what I'm going to do is that I'm going to redesign something more boxy. Let me just plug this in. This should be 31 millimeters. Got it. I'm using my guidelines here and the grid to precise sketching. Great. So I have my profile here. I'm just going to select this, hide it for a sec. Make this a little bit smaller so I can get all the profile and cut it right through. This should be 35 millimeters, and I need to union them. So now that I unioned, you can see that there are some excess faces here. I'm going to select these faces and I'm going to remove them. So now I have to create the hole, as I mentioned earlier. So we need more of an angular overhangs. So what I'm going to do now is that I'm going to offset these edges and start preparing that hole. Let's make it 7. This should be 21. Great. 21. Great. Now I need to do the teardrop on the top. I'm going to use some guides here to create a teardrop, trim away this edge that I don't need. And I already have this profile, which I'm going to use to cut through my body. So one thing about direct modeling is, which is great, is that you can later on go back. And for example, if you want this, if it turns out that this hole is not in the right place, or it should be moved because of some issues, you can just grab these surfaces and you can move this around. You can even scale them. Or you can just grab but one face at a time. And you can, for example, say that, oh, this should be 22. So this should be on the same plane as this one. So great. So this was the first part. And now I'm going to go to the second part, the second mount. I'm going to remove first some material, which should be 0.5 and 6. Great. Let's remove some material and add a fillet. I'm going to start adding fillets now. This should be 6. Let's add a fillet here as well, which should be 22, and add some chamfers as well. Again, add fillets as much as possible to ease the stress on the corners. This should be 7. Great. So now I need to create this mount that attaches this part to the machine. So this should be on the same plane as that mount. So what I'm going to do is I'm going to project this edge to this plane to use it as a reference, then go to that plane and start modeling. I'm just going to model one part of it, and then later on I'm going to mirror it. This should be horizontal and vertical. Let's use some guidelines here. This should be locked, and these two should be horizontal. Now I want this to be 21. Now I want this to be 8. It also needs some sort of a wall thickness, so I'm going to go back to the same method I used previously and offset these edges 3 millimeters. I also need to add a small part here. Let's log this in. Let's make these horizontal and vertical. This should be 4, and this should be 2.5. And finally, let's remove this edge. And now you can extrude it. This should be 5. And you can see that it's only the half of it. So now what I'm going to do is that I'm going to mirror this part, and I'm done. So now we have all these parts, which I'm going to union. You will notice that I did make some mistakes here. So let me just hide these. There are some parts which are not connecting properly. And this is what you can do in direct modeling. You can just grab these faces and you can directly edit them and see where the problems are and address them directly. Let's make this 6 on the top as well. Great. So now what I need to do is create this hole that where the ball valve goes in and the push rod goes out. So I'm going to create the profile for the hole and then sweep it across my body. And first, I'm creating a line to make sure that this rectangle is positioned in the middle. Make sure it's 7 millimeters. Again, and we are aiming for angled overhangs. So this rectangle might not cut it, but if I rotate it 45 degrees, that should be good. Great. What I also need is a feature, a small curvature on the side that eases the ball valve's path into this hole. So I'm going to create a small curvature here. Well, also I'm just going to lock this, let's make this tangential, and now I can freely dimension it as the constraints are all there. So now that I have this profile, what I need to do now is that I'm going to sweep across these edges. So I'm going to select these edges. And you can see that on the left side, I already have these tools offered to me by the app. So one thing that we try to make it easier for you within the app is that to offer those features that might help you not think, just select those tools that are possible with your current selection. So I just hit sweep and it's done. So I can just remove this. Again, selected the 2 bodies and hit subtract. I actually want this the other way around. So I'm just going to change that. And I don't want to keep all the modified bodies or the removed bodies. So I'm just going to hit done and it's ready. So now what's left is to add those chamfers and fillets. And I'm not going to do all of them because we are running out of time. I'm just going to show you how you can precisely dimension your chamfers and add fillets as well. I'm going to select a couple of edges here. And notice that the app actually notices that your fillets are actually continuous and you don't have to select all of the edges. And direct modeling makes it available that all of the features are saved. And while you modify these faces, it will remember that those fillets should be there. One thing that I forgot before we move on to Lutz, that I forgot to add this curvature. I'm just going to extrude it into the body and union it together. And it's done. Let's hide this again. So if you don't need this, it's fine. You might not need it after all. You can just delete it. Again, direct modeling, you can delete certain features just going back. And to jump to the final part, this is the final part that I sent to Lutz. And the way that I'm going to send it to him is that I'm going to export it as an STL file. In Shapr, you are able to export it in a high quality, but you also have the option to export in where you customize the tolerances. But I'm just going to do high for now, and I'm going to send it to Lutz. And yeah, Lutz, take it away. I think you have the files.
Yeah, thank you, Daniel. I mean, this is just, for me, this is just fantastic to have an app on an iPad which allows you to take any kind of CAD geometry and modify it as you wish. I have now opened what Daniel sent to me on our slicing software, which is our cloud-based Eiger. So what we want to go to do is now using this geometry, slice it and dice it and print it. And my printer is actually running. So I will show you, I have a camera installed so I can show it live to you basically. So, I mean, the first thing we got to do is select the material. Our Onyx actually is a nylon 6 with kind of 15% of chopped fibers in it. And you also can see the steels and the coppers we have for our metal printing. For now, we just use our standard nylon material. And for reinforcement, I know from my client that this part here has kind of some impactful things to withstand. So it has a lot of impacts during his life cycle. So I choose, instead of carbon fiber or fiberglass, I choose Kevlar because Kevlar is known for its impact resistance as well. And I choose a printer. I have some more settings, which is, for instance, the infill. As some of you know, plastic parts are not printed in full material. In the inner sections, we do kind of produce a triangular fill or others. I can just justify this by specifying the type of fill I want and the roof and the floor layers. So at the walls, keep 2 layers of massive material. At the roofs and the floors, keep 4 layers of massive material before you actually start the infill. Now I go for the reinforcement. And I think I can better show you the way we reinforce by simply showing you an internal view of the part. So here is basically the inner view of this part. And just to explain to you the process, this is now a 2-dimensional view layer by layer. And you can, let us jump to this layer, for instance. So what you see here is actually all white lines are basically plastic. So this is our nylon 6 with chopped fiber. And the yellow lines are actually continuous strings of Kevlar. Continuous means really continuous. So how do we do this? Well, I think the best way to show it to you is basically to show you the camera. I hope you can see this now. This is actually live, a webcam on my printer. So what this technology is actually doing, I mean, you can basically see it on the part. The yellow lines are actually Kevlar. So we basically have 2 nozzles in this printer. One nozzle is doing the plastic, the nylon. And the second nozzle is actually laying down a constant string of Kevlar fiber, and it's cutting. There is a little cutter in this nozzle, and it's cutting it and starting with the next one. So the end result is actually a super strong part, which is of uncomparable strength to what you may see in other plastics and with chopped fibers alone. So this was kind of a little live video of the printer doing something. Now switching back, I have the ready part here with me. So because I've already printed it quite obviously in preparation. So yes, we do. This part has Kevlar fibers internally, but you cannot even see it on the outside. We have with our printers, I would say, almost an unparalleled surface quality and stability in this part. So let's move over for a short second to the presentation again. Our software, by the way, does a lot more. You can manage a fleet of printers, so you can always have a close look at the uptime or downtime of your printers, material consumption, predictive maintenance. All this stuff is covered by basically our Eiger software, which comes basically with each printer. Usually we get a lot of questions in regards to our continuous fiber process. And a friend of mine in my company made a really nice video about it. So please enjoy.
Continuous fiber printing is a variant of a deposition-based printing process called continuous fiber fabrication, or CFF. One nozzle builds a thermoplastic matrix material while continuous strands of fiber are ironed down into the part with a second. Software allows you to lay these fibers down in specific places with specific settings to optimize the part for its strength, just like with traditional composites. So a part reinforced with continuous fiber leverages the strength of the continuous strands themselves rather than relying on the thermoplastic for strength. And we can show what a difference that makes right here. So chopped fibers are basically a bunch of little pieces of a strong material adhered together in some way, like how these bricks are held together by their connection points. A continuous fiber takes that same material but forms a continuous connection across the loading surfaces of the same part, represented by these plates on the top and bottom. So when we apply a load to a chopped fiber part, it breaks at the connection points, which, when applied to printing composites, is just the thermoplastic holding it all together. When we apply this same load to a part with continuous segments spanning the load paths, in this case the top and bottom plates of the part, the chop segments act as a filler or a matrix material, and the load holds because it's being distributed across the loading surfaces by the continuous reinforcement. This concept is what makes the continuous fiber so much more powerful than chopped. I hope this clarified some of your questions about 3D printing composites. Happy printing.
So thanks for this explanation. I think the Lego brick example is actually a perfect example to show it in a very, very easy way. In real life, this is a real difference. We now see more and more printers offering nylon with chopped carbon fiber, but chopped carbon fiber does give you a tensile strength from approximately 50 megapascal up to, let's say, 100. In an ideal world, it's 100 megapascal. Our carbon fiber reinforced material reaches 800 megapascal, which is 8 times the tensile strength of chopped fiber, because of the explanation you just saw. So this is a difference, and it's the first time in history that actually continuous fibers can be laid in geometries. I mean, I remember back my time studying material science, and we are using this carbon fiber mats and epoxy hearts, quite obviously, to do this. This has changed, you know, and I think our technology provides you with together with Shapr3D, with an ideal, almost ideal scenario in how to do this. With this said, we are almost at the Q&A, so we wanted to be quick, but we have a special promo for you. In the following countries: Hungary, Czech Republic, Austria, Switzerland, Germany, Belgium, and Netherlands, together with our partners Mark3D Benelux, 3D in Hungary, 3D Visor in Czech Republic, and Algona in Germany, you can get, with every purchase of a Mark II, X3, X5, or X7, or Metal X, you get a free iPad Pro and a pencil and a 6 months free access to Shapr3D. So this is our gift for those who are watching us live. If you have considered for going for a Markforged printer, there is some additional value for you in having an iPad Pro and Shapr3D for free. So we were quick. Daniel, good job. 26 minutes. So
perfect.
We go for questions. Lisa.
Yeah, sure. Thank you, guys. An anonymous attendee is asking, which file formats can be opened in Shapr3D?
So I think it answers Frank's question as well, but this might be an Eiger question, but I can answer the Shapr first, and then we can go to the Eiger, what Eiger can import. So in Shapr3D, you can export both meshes and solid models. So in terms of meshes, you can import STLs, and in terms of solids, you can import the native file format of Parasolid, which is XT, and you can also import STEP and IGES, and you can also import 2D files, which is DXF and DWG.
Great, thank you. This is for Lutz, I think. The same person asked, which file formats can be opened in Eiger, basically?
Well, we can import STLs and object files.
Great, thank you. Next questions from Johannes. Sorry, my German is very bad. Are there any functions for topology optimization in Shapr3D, or can it detect invalid overhangs or restrictions if you preset those?
So in Shapr3D, you can do that, but I assume that Eiger can do that. So what I would recommend is to send it to Eiger and then go back and forth. Again, with direct modeling, you can simply just move those edges, and you can correct the design.
As I said earlier, I've submitted some design guides. Actually, I have to say, if you look at our technology and you think about generative design, there are some limitations for us because our fibers are laying down in an XY area. So if you want to use generative design software, you need to make sure it has the boundary conditions of just being available in XY. So that's one of those points.
More questions. How do you stress test designed parts in Shapr3D?
Great question. Again, what I can recommend is, because Shapr is a great tool to use in coexistence with other CAD tools, I would recommend you to use SolidWorks or something else to do these stress tests. This is not something that is currently in the package of Shapr3D. Shapr3D is at the moment is mostly for modeling, for direct modeling.
So we have one more question. Is SVG import on the roadmap?
Great question. Again, I think it's on our midterm roadmap. It's definitely not something that we're going to release in the next few months, but it is something that is often talked about. So hopefully we will be able to release it in the next year or so.
Can you do assemblies in Shapr?
Many Shapr questions. I love it. Not yet. Not yet. So what you can do is that you can import all your files and align them together. But in terms of like traditional assemblies, so when the parts are separate and there is an assembly file, this is not something that you can do in Shapr. You are in a multi-body design environment, and then in that multi-body design environment, you can move your parts around. You can align those parts together.
Which design rule for metal additive manufacturing is the most important?
Well, the most important actually is to avoid too many support structures. We have a patented technology, so in our metal printing process, we have also two materials in the printer. One is actually the metal, and the second material is ceramic. So when support geometry touches a part surface, we actually put in a layer of ceramic release material, and after sintering, you can basically use a hammer and bump it away. The problem is this does work for open outer supports, but if you have a lot of inner supports in holes, for instance, so here comes this kind of teardrop design. The function of the hole is basically the same without making your support release process too ugly.
Thank you. Are there any tutorials available for Shapr3D to practice and learn before buying it, Daniel?
Yeah, sure. So first of all, the app is free to try. If you download it from the App Store, you can just directly jump into to modeling. There is a paywall if you want to export it, but trying out all the 3D modeling and what the app is capable of, you can do that in the free version. As for learning how you can do that, we have tons of tutorials on our YouTube channel. We have a quite lively discourse group, a forum where you can ask questions from other users, or we have on various social channels. We have a very active Instagram where you can talk with users as well. We also post every week. There is a new tutorial. Every week there's a new modeling video.
Thank you. Great. We also have a question about discussion groups and so on, but I think your answer was very complete. So this is an answer to this question too. Next question. Is there a part size limit? And how will it work with larger parts assemblies?
I assume this is for the printer. I mean, please visit our website. We have various types of different printers with different build sizes. So in the case, what you saw right now was a Mark II, which is actually our, what we call desktop machine. So there is certain limitations in size. Our flagship printer is an X7. He has double the print volume, I mean, size-wise and height, like the one you just saw here. And we are aiming for getting bigger. I mean, this is one of the basic things in 3D printing: faster and bigger, faster and bigger. So that's what we are designing on in the moment in our headquarters, and you can stay tuned to see more from us.
Great, thank you. Lots of questions, guys. This is amazing. We have Bashkar, I think that's the pronunciation, and they are from Taiwan. And for the printers, how can they have a quotation? Are there distributors in Taiwan?
Absolutely, we do have partners in Taiwan available. So probably the easiest way is to go to markforged.com and do a quote request, and this will be forwarded to our Taiwanese partner.
Daniel, in the Shapr3D, can we do modification on STL files?
Yeah, you can. After you import them, you can do all sort of modifications with the help of boolean tools. So you are not going to be able to move around the different vertices, but what you will be able to do is to create geometry, and using the boolean tools, you will be able to modify that STL in quite a big way. Yeah.
Thank you. Peter asks, is it possible to use also materials of other suppliers in the printer?
This question I got frequently asked. We see ourselves as a closed system. So we use our materials, we use our software, our technology. The point is, we see ourselves as machining machines. We produce parts, and with high reliability, with high quality and high repeatability. I mean, you may want to do the same part over and over again. Reliable, repeatable, and accurate. So we are a closed system. You can only buy materials from us.
Thank you, Lutz. Can we use Markforged to obtain CNC code? Interesting question from Lucas.
No, actually not. Part of, security is of high concern for an organization like us. This is the reason why we are, as an organization, ISO 27001 certified. This is the highest possible IT security certification you can get. I think we are the only 3D printer provider who is at this level certified. And this is not only true for our infrastructure and our cloud infrastructure, it's also true for our files. Our print files are MFP files. They are 128-bit encoded. There is no G-code. Basically, there was a reason for it. G-code wasn't enough because of the fiber laying down process, which requires additional commands which are not available in G-code. But anyway, no, it's 128-bit encoded, which gives our clients another layer of security. Because, quite obviously, you can build out geometry out of G-code. So it's kind of a loss of IP at this point, which you don't want.
Marco's question, I want to design gears in Shapr3D and print. Is there a library to generate the teeth according to international standards?
We don't have a library of gears at the moment in Shapr3D, but you can import from any sort of sources.
Thank you, Daniel. Peter is asking, which material will it be possible to use when printing besides onyx?
Well, talk about plastic materials here. Besides onyx, we have an onyx ESD, which is for electronical environments, basically. We also have a nylon white material, which is quite obviously without any chopped carbon fiber. That's it for plastics for now. In metal 3D printing, we have stainless steels, we have various types of tool steels. With Inconel, we have a high temperature steel for high temperature environments. And we also have released, by the end of last year, 99.8% pure copper. And right now we are the only FDM printing company which is able to print copper and get copper sintered and produce 99.8% dense copper parts.
Lots of questions. We will answer all the questions. If we don't have the time to do it now, of course, we will email the answers to you. Are there any plans to also make Shapr3D for Android available?
Not currently, but what we are going to do to expand our reach, so we are going to go to Mac OS very soon, and we are also working on a Windows version, which you can apply for the beta on our website. So that's the first stage to expand our reach in terms of devices. Android is not something that we are actively thinking about, but it might happen. But first, we are going to focus on the mouse keyboard. So currently, it's only with the Apple Pencil. First, we are going to focus on the mouse and keyboard, then Mac OS, then Windows, and then we will see.
Thank you. We are getting some questions about prices. You know, how much Shapr3D costs, how much Markforged printers cost. So could you say something about that, please?
Yeah, so Shapr3D costs either in the monthly subscription, it costs $32. It varies across app stores based on the taxes that you have in different countries. And it costs, if you buy it for a year, it costs $240. Again, it varies across different countries based on the VAT. You can either buy it on the App Store directly from the app, or you can buy it on our website where you can give your company info. And if you are a company, I would suggest to do it on our website.
Well, for the printers, it's a little bit more difficult. Since we have various types of printers, we have our desktop series. The one you saw here on stage was a Mark II. This printer is capable of printing all of our plastic materials plus all of our fibers. So this is kind of our desktop entry model. It's about 20,000. Let's call it dollar because it varies from region to region. And our flagship industrial printer, which is the X7, is at $70,000.
We also have Patricia, who's from Australia, and she's asking how efficiently can assistance and maintenance be obtained for the machines from Australia?
Easy to answer. We have really very good partners in Australia down there, and they offer their clients what we call a success plan for the printers. We have typically a few parts in a printer which wear from time to time. So they need to be replaced, whether it's the nozzles, the belt drives, Bowden tubes, all kinds of stuff. This is all included in the success plan. So those spare parts who wear from time to time, and there is a replacement schedule coming with the printer, are covered by the success plan, as well as a first level support from our local partner. And we have partners out there in Australia in every major region.
Really, lots of questions. This is great. Is the current continuous fiber strong enough to replace conventional materials such as aluminum and steel?
Absolutely. So with the continuous carbon fiber, we actually reach a tensile strength of 800 megapascal, which equals standard aluminum. So this is what you can expect. The thought process also needs to be, as we just showed in our little demo, let's call it like this, is you need to design for additive. So there is some upfront thinking, because you may assume that in comparison to aluminum, the strength distribution is not uniform because we lay the fibers in XY. So yes, with the infill and some diagonal fibers, and we can turn it by 45 degrees and stuff like this. We can, in this direction, in the XY area, you have your part can be in perfect condition to achieve 800 megapascal. But in this case, not in the Z direction. So your part orientation and your part print need to be a fit to actually the part use at the end, and where you have these stresses and strains applied.
Thank you, Lutz. Maybe we can take 2 more questions, guys. What do you think?
Yeah.
Are there any features for additive design in Shapr?
Yes. So the question, the answer is again, Shapr3D is currently only for the modeling part. So additive design would require finite element analysis, which we currently don't have, and it requires a lot of power. So this is something I guess we will do in the long run, definitely not in the next 2-3 years.
Great, thank you. Sander is asking, you announced titanium as a metal. When will it be released, Lutz?
Well, the current plans are quite obviously delayed based on, well, it has something to do with the current situation. I mean, we need to take care of our existing clients. So our main focus throughout the COVID crisis, which we are still basically in, was on manufacturing our existing materials, which reduces basically the power we could spend in developing new materials. Titanium is still on the list. I cannot share any release date as of now. Sorry.
Thank you, Lutz. So we will be happy to answer all the questions by email. And we do want to thank everybody for being here with us today. This was a great live demo and also lots of questions from you guys. Amazing. And as Lutz and Daniel mentioned, please follow us on Twitter, Facebook, LinkedIn, Instagram, and check out our websites. You will have lots of information about our technologies and also our customer stories and much more. And thank you very much.
Thank you, guys.
Thank you. Bye-bye. Thank you.
Bye-bye.